So let's talk a little bit about positive definiteness of the matrix A and how we can check whether the matrix A is positive definite. First, before we start, the way your matrix A looks will probably depend on like which way you've decided to isolate your B vector. So what you've done up till now is you've written up the matrix system, the matrix system AU equals, no, A, not AU, sorry, A, well, you probably done it with V because V is the matrix, is the vector used with the lexicographic ordering, so you've written up AV equals B. And depending on like which side of the equation you've decided to isolate stuff, the signs might be different. So if you want to show that A is positive definite, you have to ensure that what you have on your right hand side is minus k times Fij. Oops, just gave you a little clue there, but just so you know, because or else you might have that everything in your A matrix has the wrong sign. So that's something to think about. Anyways, if it has the wrong sign, you can just define the new A matrix, which is the old A matrix multiplied by -1. So it's not that big a deal. Let's look at test 3, which is a test we use to check whether A is positive definite. And it says that A is positive definite if following 4 points hold. A is positive definite if 1. Ri less than equal A I for all I. And when they say for all I, it means for I going from 1 to m times n, because your A has m times n rows and m times n columns. And what does Ri mean? Ri means the sum of all the elements in a row excluding the diagonal element. So Ri equals the sum of the absolute value of all the elements in that row except for the diagonal element, which is precisely that element which satisfies that I is equal to, that J is equal to J equals to I. So J must be different from I. This is also what you have in your formula 623. This also means, with other words, aka A is diagonally dominant. So we require that A is diagonally dominant in order for A to be positive definite. Okay, 2. 0 is less than 0 is less than AII. This is the second condition. This means that the diagonal elements of A must all be strictly positive. And that's also why I said you probably, if you encounter problems with this, then you just change the sign on both sides of the equation and then, well, you're home safe. So let's see. Next two conditions. Number 3. There is at least one row where the row sum is strictly less than the diagonal element. Where Ri is strictly less than AII. So try to find some row where that is satisfied. I assure you it is possible to find such a row. Just look at the matrix shape. Look at the shape of the matrix. in your book and search, and you will find. So the last criteria that we need to check for in order to see if A is positive definite is whether A is irreducible. Oh, this is a dangerous word, and this is what we will use the next video to explain about. So how do we check that A is irreducible? Well, that probably takes a little bit of time, but you can start by verifying that these three hold, because they do hold. And let's look at number 4 together in the next video.